We're going to do an example of the area between two polar curves. I color-coded my particularly bad graph, but you'll see what I mean in a sec. So, example 1, let S in red be the shaded region bounded by the curves r equals 2 cosine theta, r equals 2 sine 2 theta, and the polar axis. So that's this red section right there, right? So the red section is is area S. So part A, write an integral expression for the area of S, and part B, using a calculator, find the value of the integral. So part A is what you would be asked to do if it were a non-calculator section. So the first thing we have to do is we need to figure out which curve is on the inside and which curve is on the outside. We don't have to do that first, but it's a good starting place. So the easiest way to do that is you can look by visual inspection when theta is 0 at the polar axis, right? So like this blue line that I just drew, theta is 0. So one of the curves has a value of 2 when you plug in theta 0, and the other one has a value of 0. That tells you which of these two curves is which. So you can tell that when I plug in theta is 0, r equals 2 cosine 0, this one comes out to be a 2. That means that that's this outside curve. So this it must be the outer curve, right? I'm going to write out next to it. And the other curve, this guy, the one that has a value of 0 at 0, this must be the inside curve. So I now know which curve's on the outside and which is on the inside. The next piece of information I need to ascertain is I know the first bound. I know that this area starts when theta is 0, but I don't know where these two curves intersect to end the area that we're looking at. So I need to figure out where these two curves intersect. So I need to figure out where 2 cosine theta equals 2 sine 2 theta. So assuming that I don't have a calculator, that's going to require a little bit of knowledge about the unit circle. So the question is, when is this r equal to the other r? So when is 2 cosine of theta equal to 2 sine of 2 theta? Well, that's when cosine of theta equals sine of 2 theta. And I know a trig identity for sine of 2 theta. I know that that's when cosine theta equals 2 sine theta cosine theta. So that's going to happen if I subtract the cosine over when 0 equals 2 sine theta cosine theta minus a cosine. That means that there's a GCF of cosine. So if I factor out a cosine, I'm going to get a 2 sine of theta minus 1. And it seems that these things are equal either when cosine of theta is 0, right, which would be at pi over 2, right? That happens here and at pi over 3. So either when theta is pi over 2, and I didn't mean pi over 3, my bad, I meant 3 pi over 2. Sorry, it's late and my brain is tired. I meant this guy. Or when sine of theta is 1/2, which is when theta is pi over 6. And that's definitely the answer I'm looking at here, because if you look, whatever angle I get should be this nice angle in quadrant 1, which is very much a pi over 6. I wrote a 2 down there despite saying pi over 6. Seriously, my brain is failing. So I want pi over 6. So it turns out that my bounds are 0 and pi over 6. So to do part A, what I need to know is that the area of S is going to be 1/2 the integral from the first bound, which is 0, to the ending bound, which we established was pi over 6, of bigger, like the outer r squared, right, which is going to be 2 cosine theta quantity squared. And you can either write it that way as 2 cosine of theta quantity squared minus, and then the entirety of the small r, which is 2 sine 2 theta whole quantity squared, with respect to theta, and that's great. If you want to clean up those squareds a little, you can. Again, the word of caution I'd give you is that if you clean this up and do something wrong, the AP is not very forgiving. So if you want to make this a 4 cosine squared theta, fine. If you want to make this minus a 4 sine squared 2 theta, fine. But if you accidentally make an error when cleaning that up, the AP is not going to be forgiving. Because there is that 1/2 in front, you could distribute in it and clean things up a little bit. Again, I caution you that the more you clean up an answer, the more you risk making a mistake. Now, when I go to do part B asked me to put this in a calculator. So I did all the heavy lifting. My calculator is just going to do the integration for me so that I don't have to get completely and totally miserable. So when I go to put this in a calculator, right, B is all about typing. There is no work, which is why on an AP this wouldn't actually be part B. The whole question would be part A, or this would be, if there was no calculator, there would be no part that is like part B at all. But they wouldn't make this a separate question because there's no work to be. It's just typing. So what I'm going to do is I'm going to make sure when I go to mode, right, I'm going to go to mode. I'm going to be in radian, as always, and I'm going to be in polar. When I go to my y equals, I'm going to put my r1 as the first function, right? I always put them in the order they're given to me. You don't have to, but that way I always know what order I'm working with. So I made R1 the 2 cosine theta. I made R2 the 2 sine 2 theta, right? And then I'm going to go ahead and quit out of that. And then I did math 9, right? Math 9. I put the 1/2 in front of the math 9. You don't have to. But if you put it inside the parentheses, it needs to go in front of both of the r's that are squared. So I did 0.5 and then math 9. And I went to vars, right? The way I got that R1 is I went to vars, right? I went over to y vars, and I went to polar, and you'll find the r's there. And then I squared it, and I did the same thing with the R2. So I did R1 squared minus R2 squared, comma, with respect to theta, from 0 to pi over 6, and I hit enter, and I got my answer that is a 0.649 or 0.650, depending on if you round or truncate. So again, the AP doesn't give you credit for calculator skills, as in you can't write them down, but if you don't have the calculator skills, you're going to run into a real problem on the AP test.